Hi, hello, this is your Lakshma Reddy sir. Now we are in Thermodynamics assignment Numericals part 3. Right? चलो कुछ करेंगे thermodynamics में ये thermochemistry है. This is one very interesting point. You see, H2SO4 plus 2 KOH gives rise to K2SO4 plus 2H2O. H2SO4 is a strong acid, KOH is a strong base, and you are getting here 2 moles of water. According to heat of neutralization, when 1 mole of water is formed, the energy released is minus 13.7 kilocalories. And when 2 moles of water is formed, it is into 2, which is equals to minus 27.4 kilocalories per mole. Okay. For the reaction 2H2O gives rise to H3O plus OH minus. See, one interesting point is here. H3O plus means it is water only with H plus. Okay, now don't think that 2 water molecules are broken. Only 1 water molecule is converted into H plus and OH minus. As we know, H plus join with OH minus to form water. In this case, the energy released is minus 57.3. Here he is asking reverse reaction H2O when turns into H plus and OH minus, how much of energy is required? Delta H is equals to plus 57.3, right? Equal volumes of equimolar HCl, H2SO4 are separately neutralized by dilute NaOH solution. Then heat liberated are X and Y. Which of the following is true? HCl with NaOH gives 1 water molecule. And he is saying equimolar means 1 molar. If you take H2SO4, it will join with 2 moles of sodium hydroxide to form 2 water molecules. If here X is formed, here Y is going to form, and this Y is definitely 2X, double of that. So X is equals to Y by 2. Because in this case 2 water molecules are formed, each water molecule the energy released is 13.7. When 50 cc of 0.2 NaH2SO4 is mixed with 50 cc of KOH, then heat liberated is. Here you can check with number of milliequivalents also. 50 cc 0.2 NH2SO4, 50 cc 1 NKOH, clearly it says it is excess. Because when normalities are given, both normalities must be same because volumes are same. Then that is you can expect both are in equal quantities and any of them that can be used. But here KOH is excess, so we should not use KOH here for calculation purpose. We need to go with H2SO4. Okay, now just to calculate the milliequivalents, how many milliequivalents are there? 50 into 0.2 is nothing but 10 milliequivalents are there. We know 1000 milliequivalents will give you 57.3 kilojoules. So 10 milliequivalents will give you 0.573 kilojoules. 0.573 kilojoules, or you can say 573 joules. Okay, now both options came same. So let us change this. Fine. Sorry for the typo error. Heat of neutralization for the reaction of NaOH plus HCl is something given. The heat released when 0.25 moles NaOH treated with 0.25. When 1 mole is treated with 1 mole of base, acid 1 mole, base 1 mole, you are getting there minus 57.1. Then 0.25 moles, 0.25 moles, 1/4 of this by 4. So 14.3. Given that the data for neutralization of a weak acid and strong acid with a strong base is, this is weak acid, how much you are getting here? Minus 41.8. When strong acids are there, how much you are getting here? 55.9. So whatever the difference is there, whatever the decrease is there, whatever the less amount is released here, that is nothing but enthalpy of dissociation of weak acid. To get the exact sign, take the energy that you got and minus your expected energy. This is always positive. Dissociation is always positive, endothermic. So in order to get the positive sign, we made like this. So 55.9 minus 45.8, 50.41.8. This is 0.141, 14.1. kJ, sorry. The heats of neutralization of HCl with NH4OH and that of NaOH with CH3COOH respectively are 51.4. How much we are expecting? 57.3. How much we got here? 51.4. How much is less amount here? Okay, now this is 13 minus 4, 9, and 7 will become 6. So 5.9 kilojoules of energy is utilized for NH4OH. First value HCl versus NH4OH, right? So this is the energy required for the breaking of NH4OH weak base. So weak base ionization energy, you can say 5.9 kilojoules. Coming to the next one. Okay, we will change some color of this. In the second case we got 51. So 57.3 we got 50.6. So 13 minus 6 is 7. So this is 6. 6.7 kilojoules of heat is for CH3COH weak. If both are strong, how much we need to get? 57.3. Okay, now if one is weak, we are getting 50.6. So this amount of energy is utilized for the dissociation of weak acid. Now add these two. This is for weak base dissociation, this is for weak acid dissociation. So this will become 12.6 kilojoules wasted for both of them. How much you are expecting? 57.3. How much is wasted? 12.6. Take the difference, you will get that. Okay, so that will be 57.3 minus 12.6. So 13 minus 6 is 7. So this will become 6, 4. So 44.7. 44.7, 44.7. This is 44.7. Right? This kind of questions you can expect. Heat liberated in the neutralization of 500 ml of 1NHCl, 500 ml of 1NH4OH is 1.36. 500 ml, 1N, 500 ml, this is weak base, so it is 13.6. So for 1000 ml, how much it will be? 1000 ml means 1 equivalent. Okay, so that is double of this, 2.72. But actually, how much of energy we are expecting? 13.7 kilocalories we are expecting for strong acid and strong base. How much less is there? 13 instead of 13.7, now you got only 2.7. So approximately 11 kilocalories of energy is utilized for the ionization of this. Expected 13.7 minus 13.7. Energy released is always negative, minus 13.7. But how much you are getting here? Minus 2.72. So the difference is 10.98 was wasted for NH4OH dissociation. In which of the following combinations of HCl and NaOH the heat energy liberated is maximum? First you see which is limiting reagent. Here concentrations all are 0.1 only, so don't worry about the concentrations. 10 ml, 40 ml. So this I am cancelling. 30, 20, this you cancel. 25, 25 both are equal. 35, 15, this is cancelled. Where more volumes are there? This is 10, this is 20, this is 15, and this is 25. Maximum volumes means maximum number of milli equivalents. Maximum number of milli equivalents means maximum energy. Last one, coming to the last question of this session. Under the same conditions, how many milliliter of KOH and 0.5 mH2SO4 solutions respectively when mixed with, when this is given 1 m KOH, this is okay, fine. But H2SO4 is a dibasic acid. Dibasic acid means if you convert into normality, it will become 1 normal KOH and this will become 1 normal H2SO4. So both are having same normalities. Now they need in 50-50 volumes. Okay, total 100 ml you want to prepare, and when their concentrations are same, they must be taken 50-50. If their concentrations are, that means molarities are acidity basicity are in the ratio of 2:1, then you can take in the according to ratio either this or this. Okay, now depending on which you are taking first, right? With more questions, we'll come back soon.